Okay, question 7 on the homework. Looks like a lot, but it's going to be the same process over and over. Let's see. Organisms, starting population is 8 billion, which is here in scientific notation. And it increases with a doubling time of 20 years. Suppose the population continues to grow in this pattern for the year 2000 in the future. Okay, so every 20 years, this thing should be doubling in population. So they did 8 times 2 makes 16. And so since, here, a little bit about scientific notation. This is what happens when we double the year 2000. 8 times 2 makes 16, right? But this isn't scientific notation because scientific notation, there's just one digit in front of a decimal. Here's where the decimal is, though. We have to move that digit one place to the left. And if you do that, you got to compensate by increasing the exponent by 1. Okay? Because if you work out both those numbers, they're the same thing. So again, we double 1.6, that makes 3.2. We don't have to move any digits that time. So this next one, I've got to double 3.2, that's 6.4. So I'm going to say 6.4 times 10 to the 10th. And then if you double 6.4, that's 12.8. That's not scientific notation though, so I'm not done, okay? I got to move that decimal one place to the left. That's 1.28 times 10 to the 11th. And then we've got another 20 years, so we should double again. So that's 2.56. Man, I don't know why they need to keep going like this. You get the point after a while, right? Maybe there's a reason that I'm not seeing. 2.56 times 10 to the 11th, and then we got to double it again. So 2.56 times 2 gives us 5.12 times 10 to the 11th, and then doubling again is going to give us something over one digit. That's 10.24, so that's 1.024, and instead of to the 11th power, since I moved that decimal, I've got to increase that. That's 1.024 times, oops, they want this one, times 10 to the 12th. And then if we double that again, it's still to the 12th. Double it again, it's still to the 12th power. Double again, we still should be to the 12th power. And now, if you double 8, that gets you into the 16s range. So it should be the 13th power. This is a big problem, huh? 13th. 3.2 times 2 is still going to be to the 13th power. We don't have to move. 6 times 2 is going to give us 12, so we're moving up another power. Staying on 14 for the exponent, staying on 14 for the exponent. 5 times 2 is going to give us 10. That spills us up into the next power, so it should be 10 to the 15th now. 10 to the 15th, and then 4 times 2, we're still sticking on 10 to the 15th. Brutal. A lot of stuff there. B, the total surface area of the planet, or 5.1 times 10 to the 14th meters squared, assuming that the organisms could occupy. When would the organisms be so crowded that every organism only had 1 square meter of space? So if every organism gets 1 square meter of space, and if this is the size of the place, then we're looking at 5.1 times 10 to the 14th organisms. So that's, we have an estimate right here, 5.24, so that's above. So it happens somewhere between 2,300 and 2,320. 2,300 and 2,320. Suppose that when the area needed to grow food, each organism actually requires 10 to the 4th square meters of area to survive. So we need to do a little bit of math off the side here. We have 5.1 times 10 to the 14th square meters available. But the organism actually requires 10 to the 4th square meters to survive, to go out and find food, and vegetation, all that stuff. So we want to find out how many 10 to the 4th square chunks there are here. So we're going to divide it into the 10 to the 4th equal chunks. Okay, into how many equal chunks would happen if you divide by 10 to the 4th. So in other words, take the total amount of area in your problem and divide it by the total amount of area required. And the nice thing is we don't have to do a lot of calculations because of our exponent rules. 10 to the 14th divide by 10 to the 4th. The powers subtract. So 14 minus 4 makes 10. So that's our new power. When would, in years, what time period would this be reached? 5.1 times 10 to the 10th. So 10 to the 10th is right here. It looks like it's closest to 2060. They want it to the nearest 20 years. So 2060 is the closest. This question's crazy. Suppose the organisms learn to colonize other planets and moons in their solar system. The total surface area of the worlds in their solar system could potentially be colonized roughly 5 times the surface area of their current planet. So 5 times, this is the current planet, right? So we're talking about having 5 times 5.1 times 10 to the 14th available. So 5 times 5.1 gives us 25.5, which is 2.55 times 10 to the 15th power. I had to do that trick where I moved the decimal one place to the left, so I had to increase the exponent. I was running out of room on that last page. So this is how much surface area is available. Okay, so that's, I think, was the last box. Now, oh, actually, I got to grab this number. I was running out of room on that last page. So this is how much surface area is available. Okay, so that's, I think, was the last box. Now, oh, actually, I got to grab this number.